Okay. Thank you all for coming for today's product launch presentation. My name is Jiali Liao, Chief Scientist of Vedio Biotech. In today's presentation, I would like to present a newly developed VDX series, which we developed over the last 2 years, and which have a unique separation, high binding capacity, and salt tolerant. Okay, yeah, the VDX series cover this traditional ion exchange resin, including the standard type and the strong binding cation exchange resin, which often called the salt tolerant ion exchange. And we also developed 2 anion exchange mixed mode resin and the newly IMAC resin and the CoreA. Yeah, as you know, due to the rapid development of recombinant technology, most of the newly developed ion exchange resin focus mainly on protein binding capacity. And when we developed the VDX ion exchange, we not only focus the binding capacity, we also optimize the protein interaction with the ligand, so the binding is in a dynamic binding mode, which is very different from the ion exchange resin you have been used. One of the example is if you run in hemoglobin and BSA separately, you will, and then overlay these 2 chromatograms, you can see there are some area which will be co-elute. So let's look at the difference between resin. For example, these are the typical benchmark Q resin. So you can see they just simple overlay, the red color represent hemoglobin and the blue color represent BSA. So you will see the whole mixture. When you collect the fraction, they will not separate. But the VDX ion exchange is very different from the traditional ion exchange, where because there's a dynamic binding mode, so the strong binding will be replace the weak binding and push the weak binding protein to move forward. So you can see the big difference between the VDX series product, because the BSA binding stronger than hemoglobin. So during the elution, you will find they are no longer the tailing like this one. They push the hemoglobin in the front. So you will get much better separation resolution. And also you can see even the BSA able to separate monomer and multimer. So these are the big difference, because our VDX resin, ion exchange resin, is no longer like the traditional ion exchange resin you have been used. They have a displacement effect. We also call it the dynamic binding effect, where this traditional benchmark Q resin is simple static binding mode. So these are simple by gradient elution. How about, because most people will use isocratic elution from a lot of protein. So with the isocratic elution, even the same protein, you can see because they are in the dynamic binding mode, so you are easy to find the right salt concentration to elute the hemoglobin, for example. And even there's still a little bit hemoglobin left over to the column when you try to elute the BSA, you will see the hemoglobin is just in front. So when you collect the BSA fraction, the first few fraction is hemoglobin, and then the rest of them is pure BSA. But if you look at the traditional benchmark Q resin, you can see the whole collected fraction contain both hemoglobin and BSA. And with this dynamic binding mode, you can easily to separate multimer from the monomer. where for the traditional resin, they don't separate well. So from the principle, when we develop the VDX resin, they are very different from the resin you have been used. The mechanism of the binding is different from the other ion exchange resin. As you know, when the purification of the protein often in different states, for example, capture state, they mainly need the resin with high binding capacity. Intermediate purification and polishing, they need a high resolution. Based on that, we develop H series and the H series product. For example, these are for the capture, for the high binding capacity. Our VDX-HQ have the similar binding capacity as all these benchmark. But remember, none of these benchmark able to have dynamic binding. And also the cation exchange resin, you see we have even higher binding capacity. And they also have a dynamic binding mode. For the high resolution one, you can see our HQ is similar to all those benchmarks, whether they are polymer-based or the bioreactive HQ or the Sativa several SKU. And also the cation exchange, you can see we have much better binding capacity than the polymer-based or polyargillose-based resin. These two sets of resin has been used, for example, aggregate, matte aggregate purification, for example. So you can see with step elution, you are able to get a pure, for example, that's the low, contain 10% aggregate after protein A. But with the HQ, you can get 99.16 pure. And the recovery is very high. And the street peak, you can see mainly aggregate. And the HQ resin, VDX-HQ, has been also used for AAV purification. For example, the full AAV and the empty AAV, they have been very well separated by the customer. And they also used for the recombinant protein, monomer and dimer purification by our customer too. And also the antibody impurity removal for the CD45. I also mentioned the strong binding ion exchange. Actually, they also often call salt-tolerant ion exchange. The most typical one is porous HS, which has been used for many pharmaceutical companies in Europe and America. And we have both VDX-RS and VDX-CM, which are also salt-tolerant ion exchange. And you can see the VDX-RS, and you see the porous HS, bioreactive HS, and the capital S impact, which recently launched. And you can see the difference between our VDX-RS is very similar to the other. Very high resolution and salt tolerant. And you can see the binding capacity, which are similar to all those benchmark except capital S impact, because they use 42 micron beads. But the drawback is, of course, when they, especially for IgG, such big, large molecule, and with the smaller beads, of course, you get higher binding capacity, but you are only suggest to run 100 centimeter per hour. But with our resin, you can easily to run 300 centimeter per hour. So the productivity is not lower, it's even higher, because your process time is much shorter. And besides the RS, we also developed the new VDX CM, and you can compare the CM several fast flow under the same gradient. They are binding very weak, but you can see the VDX CM binding even stronger, separate much better. So from here you can see we do the VDX, we offer a broad range with different salt-tolerant resin for our customer. So especially the high salt-tolerant resin, the advantage is they are less sensitive to the salt content for the sample. And you also can see they get very good separation as well. So we developed a whole new ion exchange resin which are different from the other resin, and they allow the customer to have different choice based on their sample and based on their requirement. And salt-tolerant mixed mold has been very well accepted by the large pharmaceutical company recent years. And we also developed the VDX MMA Ultra and VDX MMA 2A. And the mixed mold ion exchange, you can see the structure is mainly electrostatic ion exchange group together with the hydrophobic group, whether they are cationic or anionic. And you can see the difference between the traditional ion exchange resin. For example, ribonuclease will not separate from cytochrome C, but just the ligand also contain the hydrophobic group. So the combination of electrostatic and hydrophobic interaction, you can see they are able to separate very well. So the mixed mold offer different unique selectivity than the traditional ion exchange. And also another thing you can learn is that you can see under the salts, the same salt gradient, the protein coming out much later. That means this resin is much more salt tolerant. And the salt tolerant is so important for the pharmaceutical company because they are handling the antibody is 1,000 liters. So if you're coming from the second step which contains salt, you neither have to desalting or dilute it with buffer. So 1,000 liters, you may finally come out with 4,000 liters. But with the mixed mold, because they are salt tolerant, so even they have high concentration of salt, they're still able to load to the column. That's why this day the mixed mold ion exchange is very attractive by for the pharmaceutical company. And when we developed the MMA Ultra, we redesigned the configuration of the ligand. So the ligand have very enhanced interaction with the aggregate. So you can see they are all MMA mixed mold anion exchange, and the typical anion exchange. You can see for the aggregate removal with the MMA Ultra, you can see all collective fraction don't contain any aggregate. And these are the benchmark MMA. You can see only the first few fractions able to remove some of the aggregate, but all the rest of the collective fraction, they are all contain aggregate. And of course, the traditional anion exchange don't get any separation at all. So the VDX MMA Ultra is very different from all those MMA, whether they are capital here or barrette, Nivea A-Pride, they are very different. And our resin has been showing by the customer also, they are very efficient to remove antibody aggregate. So even we just launched for 2 months, and they have been very well accepted by many pharmaceutical companies to remove the aggregate. For the mixed mold, they have 2 different kinds of purification methods. For example, for the hydrophobic one, if the target protein is more hydrophobic, we recommend to use flow-through mode. Flow-through mode, that means the antibody monomer will be flowing through. You use the pH which they will not bind to the column, but the aggregate, or the high molecular weight antibody will be retained on the column, and then you can remove on the street. You can see from the size exclusion study showing the low is 90% pure, but just using the flow through, you get much higher pure and very high recovery. So you can see only the strip is mainly the aggregate of the antibody. Of course, you also can use the bind-elute mode. The bind-elute mode is mainly you let both the monomer and the aggregate bind to the column, and then you can find the right condition to let the monomer elute out and let the aggregate remain until you is using the strip step. And you can see the separation, the elution with 99%, recovery is 72%. So actually these are also very successful case to remove aggregate, as you already seen from the gel electrophoresis or by the HPLC analysis. And also some customer also using the MMA for purified recombinant fibrolactin, and they find a similar purity compared with the benchmark, but with the MMA outlet, the recovery is very high. Because we decide the ligand, the orientation is different from all the traditional mixed mode you has been used. So they have a strong binding, but they able to recover easily. And we also launched MMA2A. These are the secondary amine which have some unique separation selectivity. For example, when we run the protein standard, especially for over-albumin, if you use a traditional anion exchange, you get a very single peak. But with the MMA outlet, you are able to see look like two peaks. But with the MMA outlet, MMA2A, you get 3 peaks. And we use the HPLC to analyze these 3 peaks. Actually, they are very slightly different in molecular way. So actually, they are the different protein. But of course, maybe the manufacturer purify the over-albumin, they may use the traditional ion exchange. So they are not really get a pure over-albumin. And with the MMA2A, you can see they get much better separation and purification. And the MMA2A, the binding capacity, or the MMA outlet, they are similar to the benchmark product. But the benchmark product usually have difficult, especially if you have been used capital here. A lot of customer complain the recovery is low and hard to elute. But with the MMA outlet, because we specifically target to avoid this problem, so they are able to have strong binding, but also easy to recover. MMA2A it has also reasonable binding capacity. The MMA2A have advantages because that's the secondary amine. So if you use pH over 8 to 9, they are become non-charged. So that means for those protein binding so strong, they are able to, you can just simply increase the pH to let them elute.
What is the ligand in the case of MMA and ultra?
You mean the ligand?
Yes.
So far it's confidential.
Yeah. Like you are mentioning 2A is primary.
Secondary amine. Yeah.
So.
Yeah. We also developed the VDX NTA IMAC. Actually, Vedio have a lot of IMAC resin which has been selling very well, but still have customers said, my recombinant protein, I'm 100% sure there's a histap protein there, but they find they are not able to bind very well. So they approach us, ask whether we can develop the VDX IMAC, which can catch the histap protein more efficiently than the customer and solve their problem. And that's and we redesign the whole structure of the ligand and the base preparation. The IMAC mainly is, you can see, is IDA, NTA, and the other even stronger one is called TED. But we only optimize the NTA, and you can see the big difference between the traditional NTA and our VDX NTA Ultra. You can see the same sample, the original sample, the feed, and these are the flow through. You can see large amount of target protein in the flow through. They don't catch it well, and they have very limited. And also the imidazole washing to remove the impurity. You can see also a lot of target protein co-elute. So finally, with two washing with 50 and 100 millimolar imidazole, you lost more than 50% or 70% of your target protein. But with our newly developed the VDX NTA Ultra, you can see the recovery is much, much higher. Yeah, so we developed the VDX ion exchange is very different from the resin you are currently used. They are very unique. They have a really good advantage over whether they are the benchmark product or the bulk product made in China. So we are not trying to copy other technology. We try to create something unique and different. That's how we try to do. And the VDX CoreA is also we recently developed, and well, the CoreA technology is very well known because they start from Sativa with the CoreA, which have a mixed mode ligand with a shell. The shell contains different pore size, so the large molecule like the viral particle or the exozyme will not able to get in because they are large. And so the impurity will be able to catch in the coil. Yeah. And we compare with our VDX CoreA together with the Sativa's CoreA 400. Yeah, actually they are simple flow through mode. You just let your sample pass through the column, and the viral particle will be elute, flow through, and the impurity will be catch by the mixed mode coil. So we compare with the CoreA and the CoreA 400, which all showing very pure. You can see just simple flow through the column. You get a very pure AAV, and the recovery is also similar to the other product, the bench product. And this technology can also be used for exozyme separation purification, and you can see most people use size exclusion chromatography for the EV purification. But with the CoreA, the advantage of using CoreA is you don't need to pack a large column because they are wide and flow through. And the other is the sample will not be diluted. So you don't even need to concentrate your sample before loading to the coil column because you got a very limited dilution, and the column is just 1/10 of size exclusion column. Yeah, you can see the purification efficiency. These are the protein before loading to the column. The impurity protein after the CoreA, they are almost clean. You may see very limited. And with the size exclusion, they are both very clean. All those impurity has been removed. And of course, the advantage of using the CoreA is the sample remain very high concentration. Vedio Biotech not only launch different chromatography resin, and we have a lot of microsphere product for IVD, for magnetic beads, and for the dye microsphere. And we also have flow cytometer, nano flow cytometer, and also have homogeneous luminescent immunoassay instrument and the kit. Yeah, so due to the limited time, so my presentation is running very quick. And this, if you have interesting to have a sample or want to have a further discussion, you can visit our booth, and we can share the information with you. Thank you for coming.